Here I'm looking at question number 7, talking about ionization energies. So we got a partial graph here. The first question asks you for an explanation. I've drawn a picture for lithium. I'll now draw a picture for neon. It's important that you recognize the nucleus matters. Neon has 10 protons instead of 3. Those 10 protons draw the electrons in closer. So even though there are many electrons, they feel a strong pull from the nucleus. This is the proper explanation. You were taught as a child that look at the electrons, and that has some value, but it's not an explanation. Why is one electron easy to lose? It's not necessarily easy. If I looked at this picture, 10 protons, 2 electrons, 1 electron. If you only look at the electrons, you'll be completely wrong. The ionization energy for this picture, 519 kJs per mole. That's this nice low value right here. Ionization energy for this picture, about 2100 kilojoules per mole. Much more difficult to remove the electron when you have the 10 protons pulling at it. There it is. If you just looked at the electrons here, you might think, oh, ionization energy should be low. It just has 1 electron. But the ionization energy here is 23,000 kilojoules per mole. Insanely difficult to remove this electron. So look at the forces. Not the pseudo-knowledge that you learned in 8th and 9th grades. This is what matters. Electrostatic attraction. 7b asks you to extend the line in 2 directions. Elements 1, 2, elements 11 to 18. So you can see there's room here in the beginning, because lithium is element number 3. So there's elements 1 and 2 to precede it. And then room here to continue the graph to higher atomic numbers. So that's what it's asking you to do. If you don't think, you may just say, boop, 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 boop. Let's just keep it going there, right? It's clearly some kind of linear trend. But you're supposed to think and look at your periodic table. Neon completes the second shell of electrons. Here's my picture over here. Neon completes the second shell, which means element number 11 is sodium, beginning the third shell. Structurally, sodium looks kind of like lithium. It started a new shell. So sodium is way down here in its ionization energy. So we're going to drop precipitously to start the third shell. Then, as you add protons, this gradually goes up. Element number 18 on the periodic table is argon. So this is the 3rd row of the periodic table. That's why it's periodicity, it's periodic, things repeat. After argon, it's going to repeat again, right? Neener, 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 neener. How about before lithium? The element before lithium, atomic number 2 is helium. Helium's way up high, even higher than neon. So, boom, there we go. Helium's way up high. It's a noble gas. It has only 1 shell. So when we look here and say, how tightly would the first shell electrons be held? Very tightly. Hydrogen's kind of an anomaly. It's around here. It's not a metal. It has a pretty good hold on its electron because that's a first shell electron. So even though hydrogen has only 1 proton, the electron is right next to it. And therefore strong hold, relatively strong hold, because it's in the first shell, very close to the nucleus. All right, so here's the proper graph. You can see it repeats. Up, up, down, up, down, up, down, up, again and again for each row of the periodic table. This is the pattern expected.